Hello, everyone, and welcome to another session of our Day One and Beyond series, where we take you through various topics and activities related to building out on Oracle Cloud. Our session today will cover designing a cyber resilient architecture, the solutions that are available today, some advantages you have, and how easy it is to get started. I'd like to introduce Kurt and Tal as our main presenters today. And now I'll hand it over to Kurt to begin today's session. Thank you.
Thanks, Brandon. I'm Kurt Hagerman. I'm a field CISO with the North American Cloud Infrastructure Engineering team. Been with Oracle about 6 years and have a almost 40-year career in security and IT. And have my primary role is to be the point of the spear for all things OCI security. So happy to have this opportunity to present this topic to you. Tal?
Hi, everybody. My name is Tal Altman. I'm a director in our OCI Network Specialist team, and I work with many customers on our cross-functional security programs, including cybersecurity and cyber resiliency. My career has spanned over 29 years, covering networking, security, virtualization, private cloud, and public cloud. So happy to be here today with Kurt and happy to talk with all of you today.
So a quick agenda. We're going to introduce what we call the cyber triad, and then we're going to move on to talk about some cybersecurity basics and concepts, and then also the concepts and recommended controls around cyber resilience. And then we'll have some implementation details with some demos that Tal will present. And hopefully you find this all useful. Well, let's get started. So, cyber resilience is a relatively new term that's cropped up. Most folks are familiar with disaster recovery as a way of helping guard against failures, like network failures, equipment failures, power outages, data center issues, those kinds of things. But DR doesn't address data-driven attacks like ransomware, where a threat actor will get into your systems and encrypt or otherwise, mess with your data, I guess, the easier way to say it. So, cyber resiliency is not the same as data resilience, as disaster recovery. So it's not just standard backup with DR. It requires some very specific controls to be implemented in order to protect your backups from being also compromised by the threat actor. So, enhanced data integrity checking is very key at all stages. So you don't just back up the data and hope it's good. You have to do integrity checking during the backup. You have to do some scanning for malware after the backup to ensure, and you have to do some testing of that data to ensure that it's actually good data and can be used by the organization. And we've highlighted in here assume breach. This whole idea behind cyber resiliency assumes that you're going to be breached if you haven't been already. And how do you best protect your organization from some of the lengthy outages that we've seen in the last couple of years when folks have been hit by ransomware attacks. Another set of controls is really an enhanced separation of duties, architected not only into the tech, but also into processes. So we talk about, and we'll talk about later, an administrative air gap. And what we really talk about is administrative, logical, and physical separation from primary, production and backup and recovery infrastructure. The cyber resiliency doesn't take the place of operational backups. It's an enhancement in addition to what you would do from an operational perspective. Structured data also has to support single transaction level backup and recovery. This is important because of the velocity of data and the amount of data that is being collected by most organization systems. It's simply no longer acceptable to back up your database, twice or three times a day and hope you can can take a 6 or 8 hour, or 12 hour, sometimes even 24-hour, um, you know, missing, amount of missing data. And then when you're talking about recovery data, you want to make sure it's accessible, and be able to be leveraged by incremental recovery based on your RTO and RPO, right, to a protected environment that can quickly build out into an alternate production site. We'll talk a little bit more about that later, but it's very important that you not only consider just the backup part of it, but how are you going to recover? That's what seems to have been the big problem for many of the recent companies that have been hit by ransomware, is they had some good backups, but they hadn't thought through the recovery strategy, and that's where they stumbled. The other thing is you can't forget the basics of cybersecurity. I mean, being cyber resilient and having a good cyber resilient plan is great, but you still have to focus and do the things you can do to keep the people out, and to make sure that you are aware when there's any sort of malicious activity going on in your environment. So when you think about these types of ransomware threats, they are mostly propagated through poor identity controls, so compromised credentials. You see every week some new dump of credentials out on the dark web, and also lack of good patching. It seems trivial, and most of you think, well, our security organizations they're patching, they've got a good idea. Well, I'm here to tell you that that's not always true. So you really need to make sure that you're on top of your patching and you have good, strong identity controls. And one of those is to multi-factor authentication, multi-factor authenticate all access to all your data. Don't just try to cherry pick, well, this application or this data set or this database we want to protect. Treat it all the same. If you multi-factor all your access in, then that's going to help reduce the attack surface. And the reason for that is that once they get in with one set of credentials, they start looking around to see what other credentials they can find or how they can elevate their privileges to further their attack. So if you've got good, strong multi-factor authentication, that does a lot to kind of make it much more difficult for them. And then you need to monitor privileged accounts very closely. You need to have active monitoring on what your privileged accounts are doing, and make sure you have proper alerts set up so that when something that seems maybe not quite right is going on, the appropriate teams get alerted. The other thing we've talked about patching there is controlling network traffic. So the other thing that they like to do is they like to traverse the network. They'll go from machine to machine and they find network connections that are open, and allows them to get across your network infrastructure. So make sure you have good, strong segmentation in place, and as well as good monitoring of that traffic, so that you in both these next-gen firewalls are very good at being able to help you both control and inspect the traffic, and throw out alerts when something unexpected is going on. Again, keep your standard backup and recovery for operational purposes, because you've got to do that. There's people make mistakes, and you need to be able to recover from those quickly from an operational perspective. And then a lot of times people say, well, I'm going to focus on cybersecurity. You got to be more holistic about it. You can't just put all your eggs in one basket. You have to think about having good, strong defense in depth, good DR plan, and then also cyber resiliency. So we've coined the term cyber triad that consists of cybersecurity, disaster recovery, and this new circle of cyber resilience. Within OCI, cybersecurity is really, we can help you with your cybersecurity through our core landing zone. Our core landing zone is a set of Terraform scripts that help you deploy a tenancy and also other modules for your tenancy that are aligned with the CIS Foundation's benchmark for OCI, as well as OCI best practices. And we have programs that can help you get started to get the right start so you don't have to stumble through it. Disaster recovery, again, it's important, but it doesn't do everything for you. We have our maximum availability architecture for databases, as well as our OCI full stack disaster recovery service, which can help you with your workloads. You can develop recovery plans for your workloads without having to stand up the full infrastructure at another site. It can basically be deployed very quickly through code at an alternate place. And then finally, the cyber resilience, which is what we're going to be talking about the rest of the webinar here today. It's our Cyber Resilience Foundation, our Cyber Resilience Architecture program. And you think about it, you look at it, where we'd like to have all of our customers is in the middle there, where they're focusing, where they've got focus on not only cybersecurity and disaster recovery, but they've added cyber resilience. So I'm going to take you through kind of a high level of our the high level view of our cyber resilience architecture. So we are using the term we call enclaves. So we're going to walk through the production vault and what we call safe restore enclaves. So initially, you've got your production enclave. This is where you're doing your defense in depth, your operational backups, and where you're operating your business. A lot of companies have started introducing the concept of canary data sets, especially when they have very large database data sets. It allows them to more easily test and observe the data to see has there been any manipulation or corruption of data without having to try to do that across an entire, let's say 100 plus terabyte or petabyte type data set. Typically, these canary data sets are controlled by the security organization. They develop them, and then they can monitor those data sets to help the organization know when there is potential data issues going on. Then we create an administrative air gap to our vault enclave. So when we say administrative air gap, what we mean is separate identities. At a bare minimum, it's a different set of identities that can access the vault enclave from what are used in production. So people's production accounts can't be used to access a vault enclave. A better solution is to have a separate identity domain, and that can be within the same identity provider, or the strongest protection is to have a separate identity provider actually provide the identities or access to the vault enclave. That helps reduce the risk of compromise of your primary identity provider. They get that, then they get all of them. So we highly recommend a separate identity provider be used. And then also, an isolated network. So do the best you can in terms of isolating the network and making sure you have very strict rules for how data gets from the production enclave to the vault enclave. What's allowed over what ports, over what protocols, and that there's good, strong monitoring on that. And then the vault enclave can either be instantiated as a separate compartment within a single tenancy, or we're seeing a larger trend of customers wanting to actually stand up a separate tenancy altogether, because that provides another sort of layer of protection, because those are isolated enclaves within Oracle, within OCI itself. Within the OCI Vault enclave, you're going to be taking your periodic backups and vaulting them immutably. So these are going to be backups that are in addition to your operational backups. They're going to be vaulted immutably. You're going to set up automated backup testing. So you're going to, whether you're standing up, a minimum architecture for applications, so you can pump the data in and do a check to see does the application recognize the data and does it look good. You're also going to look at from an unstructured data perspective. you're going to look at doing detecting data corruption and malware in that backup data. If you're using Oracle databases, the Oracle Autonomous Recovery Service provides that detection of data corruption as part of its service. And we'll talk. Tal will talk more about the Autonomous Recovery Service during his portion of the presentation. Then next, we create another administrative air gap to our Safe Restore Enclave. Now, we've written this as optional because not everybody's ready to take this step. If they can get to the first step, the Vault Enclave, and know that they have a catalog of known good data, and they're comfortable and they've developed at least a recovery strategy that allows them to take that data and repopulate a new infrastructure with that. Some people are okay with that step. The Safe Restore Enclave is really great for companies with very large data sets. And we talk about the concept of continuous incremental restore. So think about it in this way: standing up sort of a minimum viable architecture that allows you to restore data based on your RPO and RTO, so that you're never more than like one testing cycle and one backup cycle away from having all of your data ready to go. That could reduce your time to recover from a ransomware event from weeks to days or hours. It's a very strong concept. This enclave can actually also act as a new production enclave by including automation, like through Terraform, for instance, that could take this minimum viable architecture and expand it into a full production architecture, at literally the push of a button. And that would allow you then, if you have a compromise in your production environment, to isolate it, to do the forensic analysis on it, and understand how the threat actor got in, what did they do, and build a stronger, build more defenses to try to stop that kind of activity in the future, while continuing to serve your business. And then once you've figured that out, you can either cut back to the production environment and restore data to that, or the production environment can kind of become your new Safe Restore Enclave, and you just keep the cycle going. So that's kind of the high level view of it. This is becoming more state of the art. We're starting to see companies like Commvault and Rubrik and others adopt this sort of methodology in their solutions. And when we started on this, gosh, it's been 4 years ago, this was a really, really new concept. So this is kind of what the production vault and Safe Restore enclaves look in OCI. These are the things that you would see in them. Your production, you've got an identity domain, you've got production admins, you've got the associated IAM policies, you've got all the application components, database components. The Vault Enclave is just going to have perhaps a separate identity domain with a different set of admins, a more restrictive set of IAM policies. So there's very little the action that humans can take within this Vault Enclave. And as Tal will walk you through, we have this orchestration server where we've created a code that allows you to take your unstructured data and effectively move it from a production enclave to the Vault Enclave across the control plane, so there's no network connectivity between the two. And then the same thing happens in the Safe Restore Enclave. And this is just a more sort of detailed look. So you've got the production enclave may have a network compartment and application, multiple compartments with different resources in them, and then they connect over to, you can see in the database services there through the safe service gateway, they're going to the Autonomous Recovery Service. And then you've got the Vault Enclave in the upper right, where you've got the orchestration server and the worker nodes, and the immutable bucket that we use to store all of the backup data. And we don't just store the data, we actually store also the metadata so that it makes it easier to put all back together. So we can associate which block volumes or which file file mount points are associated with each VM in the environment. So I think that's it for me. I think Tal, the rest of this. Oh no. Sorry, I misspoke there. One more thing on cybersecurity concepts and controls. So we're going to just cover the landing zone here real quickly. This is our core landing zone, and it's a bit of an eye chart. I know it's kind of hard to see, but you can see how the landing zone automatically will create the compartments that you need, the distributed administrative groups that you use to manage the resources within those compartments. You'll notice that nowhere in that diagram is there a tenancy admin group. That tenancy admin credential is very powerful and needs to be vaulted and tightly controlled. So no one should be operating in your tenancy with tenancy admin privileges, because if that particular account were to be compromised, you could lose your entire tenancy and everything in it. So we've got several templates within the landing zone for different networking constructs and different architectures that you may want to put together. And it's just a matter of choosing the right template and making the appropriate modifications. And you can see how within a very short period of time, you can deploy an entire tenancy. And you can also use this to define, like, let's say you have 3 or 4 different workload types that have slightly different requirements within your environment. You could build a landing zone for each one of those workload types. So that if you do, when you deploy the next workload of type A, you just deploy in the landing zone and it's ready for that application to be installed in it. So, just to wrapping up kind of the nail the basics, our cybersecurity, the MAP program, Maturity Acceleration Program, is what we use to help people either A, get a tenancy started from scratch, or B, if they already have a tenancy, we can go in and do an analysis of the security posture of the tenancy and come back and make actionable recommendations for how you could strengthen the security of that and get more closely aligned to the CIS Foundation's benchmark. And you can see here there's 7 domains that we measure within that: security posture management, logging, monitoring, alerting, cloud governance, network management, security, identity and access management, secure compute and storage, and database security. And we've got some of the cloud native OCI cloud native controls there listed in there. And I did see a question in the Q&A about the deck, and yes, the deck will be available after the webinar, and that'll be covered at the very end. I think now I can pass it to Tal. Thanks very much.
Awesome. Thank you so much, Kurt. So we've covered the cyber triad. We went over the cyber resiliency architecture concepts and strategies. Kurt walked you through how to nail the basics of cybersecurity utilizing landing zones, which is offered as Terraform as code. And we also kind of covered some different cybersecurity controls. So now let's dive deeper into cyber resiliency and some of the ways that you could implement it in Oracle Cloud. So it became clear in talking with our customers that they needed help implementing cyber resiliency in OCI. We developed the Cyber Resiliency Architecture Program, or CRA program, to help customers assess and improve their security posture in Oracle Cloud. We focus in 4 domains, which are above and beyond, which are covered in the cybersecurity pillar. We are focusing now on immutability, zero trust, threat detection, And lastly, backup and recovery operations. In all of this, we're assuming that customers at some point in their journey could potentially be breached. And we're augmenting your cybersecurity programs with cyber resiliency to help provide a more holistic protection strategy. So let's dive into some specific and mandatory controls that we would recommend everybody implement. So in terms of mandatory controls, the first thing is having an immutable bucket for unstructured data. Immutable buckets are object storage buckets, which are specifically implemented with a retention rule applied to it. So when a retention rule is applied, it means that for some period of time that you can define, it could be 30 days, 60 days, and so on, no one is able to modify, encrypt, or delete the content of that's in that bucket. Again, having a retention rule allows you to define how long you want that data to sit in your bucket. In addition, you can apply what's known as a retention lock. So even if Kurt is an administrator, Kurt as an administrator cannot reduce the retention period of that object storage bucket. So that's the first mandatory control. The second control that we think every customer should apply is implementing the zero data loss autonomous recovery service. I'll dive deeper into that specific service and how it works in just a moment. And third is, if you have additional mission critical data sitting in file systems, we have a managed NFS service called File System Service, FSS. We recommend that you get that data into your immutable object storage bucket. There's commercial tools and there's also open source tools like rclone, which will allow you to copy from NFS to object storage, for example. The second domain is zero trust, and there's a lot of different components in here. So let's walk through these step by step. First, in addition to having that immutable bucket, you need to lock it down, as Kurt was recommending, to just the backup administrators who need to have access to the bucket that's inside that immutable vault. So you could utilize tools like Oracle Access Governance if you have a very complex layering of compartments and policies and groups and so forth. But we do recommend having separate identity domains, separate users, groups, and IAM policies to really lock down this environment where appropriate. Network segmentation is also critical. Depending on your operations and the strategy that you deploy, one of the big challenges with ransomware and malware is that, if you restore something that still has malware on it, in theory, it can reinfect your network or discover other nodes in the environment. So we recommend utilizing a few different methods to restrict access. So for example, instead of having a dynamic routing gateway, which allows full network access between all these environments, you could deploy virtual cloud networks that only have service gateways, for example. You could utilize the Oracle managed Bastion server as a jump host to allow you to have remote access to these restored compute nodes to verify if malware still exists or if you're still seeing malicious behavior when you restore from backup. Enhanced identity, we talked through. Compartment design is critical. In Oracle Cloud, there's this concept of having multiple compartments, and there's inheritance by policies. So what we've defined in this architectural diagram and highlighted in green is this concept of implementing policy at a parent level, but not at the root level for some operations. And then the IAM policy applies to all the compartments underneath that parent compartment. So don't have one admin who has full access to everything. Try to implement separation of duties and more fine-grained granular access controls where possible. Threat detection is critical and paramount, because again, a lot of threat actors can dwell or remain in your environment for an extended period of time. So there's a few different techniques that you could utilize to minimize that dwell time. Most customers are deploying things like CloudGuard, which is Oracle's cloud-native cloud security posture management tool. You can enable detection or prevent somebody from converting a bucket from private to public access. For example, you can enable bucket logging. You can look at threat detector rules that are specific to object storage and other rules as appropriate. XDR and SIM tools is the concept of log aggregation, event correlation, and doing forensics. This is really important that you dial this in and have this capability for any workload that's in production, especially workloads that are potentially mission critical or customer facing over the internet. The other two recommendations are recommended, but it really depends on how much control and implementation you want to do. Canary data, as Kurt was introducing, is this concept of having, fake data that you insert side by side with your production data. So this could be if you have a file server, this is like extra files and folders that are intended to look like real data, but nobody should be accessing that canary data. If somebody does, that's a potential early indicator of compromise, and you should validate if it's unintentional access versus maybe permissions that are too elevated and not needed, and you could look at locking that down. Honeypots are not anything new, but these are basically decoys. These are virtual machines or Kubernetes instances or something of that nature sitting on the network, attempting to attract people to the services. So maybe it's listening like as a web server or an unpatched Windows host, attempting to draw people in. And again, if you're seeing malicious activity on an internal resource, that's again an early indicator of compromise, something you could look at for potentially locking down your environments. Lastly, backup and recovery operations. There's a lot of different things that could be done here. We're highlighting a few key things. So in terms of mandatory controls, your boot volumes, you can create what's known as a custom image, and you can export that image into an immutable bucket. You want to have a safe restore area. So it's not only good enough to have like a pristine copy of your backups, but you also want to have a safe restore area where you can test the restoration process and also, scan that new host that was restored to verify that there's no malicious data or bad actors in there still, or rootkits or things of that nature. BR3 talks about cataloging associated resource mapping. So in a complex environment in the cloud, there's a lot of things being spun up and spun down. Maybe as a cloud administrator, your application team is saying, hey, where's the L drive? And you're saying to yourself, what's the L drive? Well, now you need to go search in your storage tier for what boot volume or block volume is that L drive mapped to, or is that a FSS share somewhere? And was there maybe like, I don't know, a load balancer, and which networks were they on, and so on and so forth. A lot of commercial tools will do this for you natively or out of the box. That's one of their value adds. But if you're building something from scratch or using open source tools, there's a tool called Show OCI, which you can utilize to grab all the metadata. Like, for example, how many OCPUs and memory did I allocate to that application that's looking for the L drive, for example. So if you have to rebuild, it's important that you have all those metadata data points available. So those are some of the things that we've implemented. On the right, you'll see OCI queuing, logging, and notifications. I'll get into that in just a moment when we get into the demo. So you're probably saying to yourself, hey, Tal, you just rattled off a whole bunch of controls. Help me prioritize. Where should I start? So first and foremost, get your databases protected immediately. For most customers, 99% of their mission critical data is residing inside the Oracle database. So utilize the zero data loss autonomous recovery service. Again, I'll explain that in just a moment as we dive a little deeper. Number two, after getting your databases protected, create an immutable bucket. create that vault, create and set up the IAM principles of least privilege, lock it down. Number 3, enable your cloud security posture management tools if you haven't done that already. If you need help, we can help you with Oracle's CloudGuard, but there's also other third-party tools that integrate with Oracle and can help you with this as well. And fourth, but not last but not least, is start the actual test of backup and restores. A lot of customers operationalize their backups, but they fail to test the restoration process. So let's make sure that you not only can get data into your buckets, but you're also testing the restoration process as well. So those are kind of the 4 high-level steps I would recommend to getting started. So from an architecture point of view, again, application tier, application nodes, file systems, get that into a vault compartment, an extra copy, right? Operational backups, you can use OCI native backups for that or third-party tools if you wish. But we recommend having an additional copy, a pristine copy that you could restore from in the event that of an account compromise or some sort of malicious activity. You have a second set of infrastructure or backups that you could restore from. For the database tier, we're going to dive into the zero-day loss autonomous recovery service. So let's dive a little deeper into this and let me help you understand what this product does and how it works. So the zero-day loss autonomous recovery service is built upon our physical appliances that have been shipping for over a decade. These appliances are now available in Oracle Cloud as a managed service. So you don't have to manage any extra infrastructure, and it's built into Oracle Cloud now. We support a whole wide array of Oracle databases shown on the left. So autonomous database dedicated, Exadata dedicated, base database, and so on. We also support this in our multi-cloud offerings for AWS, Azure, and Google Cloud. And the way that this works is, we do real-time data protection. So in traditional backups, you schedule a backup. You say, oh, I want it to back up every hour, maybe every 4 hours, 6 hours, depending on your RTO, RPO, and backup requirements. And what you end up with is full backups, incremental backups, and a lot of data being utilized. So what we are doing, which is a little different, is we're offering real-time data protection. So as soon, when you first initially configure it, it'll do a full backup of your database. And then after that, we're implementing change block tracking. So as soon as a new commit is written to the database, that commit is real-time written to multiple backup nodes in a HA or no single point of failure architecture behind the scenes that you don't have to manage that infrastructure. It's done automatically for you. So we do anomaly detection, and we also verify that the backups are recoverable and compliant with all RMAN technologies that we utilize behind the scenes. So here we're offering you a zero downtime. So in theory, you can restore to a single transaction level, not only decreasing your exposure from, let's say, 2 hours to now just to one transaction, depending on what level of granularity you're looking for. So the way that this gets implemented is a few ways. First, you have to have the appropriate IAM permission to allow the recovery service to communicate to the database and to the network. You also need to allow a recovery subnet. You define this as we go into the configuration. You need to open up 2 TCP ports to allow the recovery service to communicate with the database and vice versa. And what will happen is we're actually deploying a private endpoint so that way your database is not communicating over any kind of public infrastructure. It's all private, going through your existing virtual cloud network and connecting into our managed fleet behind the scenes. So we've developed a Terraform script that can help you with this. So I'm going to walk you through how you would do this in the Oracle Cloud Console utilizing our Terraform. So this is a managed Terraform provider called Resource Manager. I'm uploading a zip file and jumping into the database tier. Now, we're going to create a label. So this way, anything that gets built from this Terraform has that prefix of BR demo. And I'm creating a custom policy in which I want to retain, and you'll see the word ransomware here. We're going to define a retention period of 65 days. So I'm going to go down to my compartment. I'm going to pick a virtual cloud network and leverage an existing subnet that I want to use for this service. So when I run apply and create the stack, it's going to start to configure my OCI tenancy. And what you're going to see here, once I scroll down, is that it's creating the security list, opening up the TCP ports. You're going to see here I'm creating a custom backup policy. And I also have allowed the service to talk to I've created the IAM policy required for the service. So now in the virtual cloud network, in Terraform, I created the security list, but I have to still manually associate it to the virtual cloud network. So here I'm just adding a new security list to an existing subnet, and that allows the communication to flow. And here you can see that the two ports, 8005 and 2484, are now open. So once these prerequisites are deployed one time, now you can go into your databases and switch the configuration from utilizing object storage-based backups to utilizing the zero data loss autonomous recovery service. All right, so now that we covered the databases, let's kind of talk through what you could do to protect the rest of your application stack. Now, what I'm showing you in just a moment is offered as sample code and is available upon request. This should complement your operational backups. Again, you want to have a second tier of backups, which are considered your pristine backups that nobody can modify, delete, or encrypt, right? What I'm showcasing here is cloud native. Again, you could substitute this with commercial or open source tooling, depending on what your company is comfortable with. And again, operational backups are a must. You should leverage OCI native technologies if you wish to do this. And we recommend having a second tier of backups for enhanced ransomware recovery capabilities. So in this architecture and in this Terraform, we have a lot of different components. You'll notice there's a lot of similarities to what I mentioned previously. What's new here is we are utilizing an OCI queuing service. We have an orchestration server, which basically discovers all the objects to back up. And then we have a worker node. So the orchestration server puts jobs into an OCI native Kafka queue. The worker nodes pull down jobs from that queue and start to execute the backups. So if you need a lot of throughput, you can implement multiple worker nodes if you wish. You can add more OCPUs in OCI. The more compute or cores you give a compute instance, the more network bandwidth and throughput you can push. Lastly, we are utilizing native logging and OCI notifications. So you can get email notifications, you can subscribe to this, and you can enable logging so you don't have to necessarily SSH or log into these nodes directly. You can use the OCI console or third-party tools to review logs and see what's happening with your backups. So let's dive into the demo. Again, we're going to start with Terraform. So we're going to go into the stacks inside of Resource Manager. And I'm going to go ahead and upload this zip file that I'm utilizing. And again, this is to demonstrate the capability. So once we go to the screen, I'm creating that service label. Everything that gets deployed will have this prefix. I'm going to go down to a compartment where I want my vault to reside. We're going to give it a network to reside. It can overlap with production because there's no routing. We have a Bastion allow list that allows remote connectivity. I'm going to configure the retention rule here for 21 days. And after 30 days, I'm going to archive the contents so my bucket doesn't grow out of control. I need to define what compartment I want to protect. We use the term application compartment. So We're going to go into a compartment. I have in my test, I have a demo test bed with a Windows and a Linux host. So I'm going to add that to my list. You can have multiple app compartments, by the way. And then here in the notifications, we're going to subscribe and send out notifications about the backup jobs. I can add more OCPUs if I need more bandwidth, and I can also provision multiple worker nodes if we need to. If I'm not using FSS or I don't want to back up certain things, you can toggle them on and off in the advanced config. So now we're going to go ahead and get this thing deployed. We do use some custom Python on the orchestration and worker nodes. So you'll see all this getting deployed. We also have all the prerequisite, virtual cloud network, route tables, security lists, gateways that are needed. We deployed a FSS mount target in here as well. So you can see here the worker node, it's E5, E4 Flex, and you can see that they got deployed. If I go into my bucket, you will see that a object storage bucket needs to have a retention rule. So you can see that this has been configured here. So let's take a look. 21 days of retention. It's scheduled to be locked, so no other administrator can change that. And after 30 days, I'm going to archive. So obviously you could toggle these settings for whatever matches your SLAs and requirements. Now we're going to look at the backups. The backups are represented as folders in object storage. And you can see in this Windows backup, you can see I have a couple folders, there's some files, and then we have a custom image to represent the boot volume. That's like the C drive in Windows, right? And then in Linux, we have, again, some sample files, folders, bin files, stuff like that, just to showcase that all the files are in object storage with a retention rule. We also create a HTML summary, and we capture the metadata about the compute instances in case we have to rebuild it from scratch. So I know that probably went really fast. So to recap, nail the basics of cybersecurity. Create a vault and safe restore enclaves. Get started with the autonomous recovery service. Protect your crown jewels. 99% of your most mission critical data is sitting in the database. Get that protected. Consider commercial or open source tools for backup and recovery. Again, it is possible to script it, and we're happy to share our sample code, but it's not a production tool. If you're utilizing, if you need something, we recommend commercial and open source tools. Build out those operational runbooks. It's not good enough to just build it and let it go. You need to test the restoration process at least twice a year. Applications change, customers and your different lines of business may have changing workloads and requirements. So you want to make sure that just because you restored something 6 months ago, make sure it still works, right? Start backing up into that Vault Enclave. And last but not least, Kurt and I published a solution architecture guide in the OCI Architecture Center. So if you do a Google search on OCI Cyber Resiliency or Cyber Resilience, you should be able to find our Architecture Center document, which goes into a lot of the same detail that we covered today.
Yeah, thank you, Tal.
Before you move forward, Brandon, there is another question. What is the cost of the autonomous recovery service?
Yeah, that's a great question. Thank you, Rena. So the autonomous recovery service, all the prices for Oracle Cloud are available publicly. If you go to the Oracle Cloud website, you can Google that. And I don't want to quote a specific value because I don't remember it off the top of my head, but I will communicate that most customers that I talk to have communicated to me that it's actually saving them money versus increasing the cost of object storage-based backups. The reason that is with traditional object storage auto backup, what you're doing is scheduling full backups and incremental backups. With the autonomous recovery service, what you're doing is enabling one full backup, and then you're implementing change block tracking. So you're only writing the deltas. So between the compression, the dedupe technologies, you're actually saving money in general, and you have a higher RPO, RTO that you can achieve. So, or sorry, a lower RTO, RPO that you can achieve because your recover point is literally close to zero, and you're not losing any critical transactions in the process. So hopefully that addresses the question. But if somebody wants to dive deeper, we're happy to engage and help you understand the details of that. And you can always work with your Oracle account team. If you have an account team assigned to you, they can help you with some quotes and estimate the cost there. There is a cost estimator tool as well that you could look at to get some high level rough order and magnitude estimates.
What if we have a 10-year long-term backup with the service?
Yeah, that's a great question. So the Autonomous Recovery Service recently introduced the concept of long-term backups. So initially it was a maximum of, I think, 95 days of retention. But yes, now we do support long-term retention. I think it's up to 10 years. And basically, there's some tiering that can happen within the backup infrastructure to help you retain and meet your retention period. So great question. Again, a lot of those details are available on Oracle's website. And if you have any specific questions that I wasn't able to answer, you can feel free to send me a message and we can go from there. So.
Thank you, Tal. Over to you, Brandon.
Thank you, Kurt. Thank you, Tal, for an awesome session today. We really appreciate your time and help, and I hope this was a good learning experience for everyone. Before we conclude, I want to leave you with a list of resources to continue your journey into OCI security. So this covers everything from foundational knowledge to hands-on practice. For structured learning, I would suggest to explore Oracle University and the certification programs there. They have some guided learning paths. And to apply those skills, we have live labs, and you can also leverage the Oracle Cloud free tier environments and our OCI tutorials. Awesome. And if you enjoyed this session and would like us to conduct personalized training for your organization, you can email us at our personal training email and we'll reach out to you. If you want to conduct, hands-on labs, we also have newly designed QuickShot Live Labs, which is an expedited hands-on learning experience for specific cloud topics for your organization. And we also have a Code Innovate program where we co-develop solutions based on your own use case. Please remember that personal training is an investment that we make in our customers to help them grow and develop their OCI skills at no extra cost to them. And our next session will be on January 22nd for our security series. In this session, you'll be introduced to the fundamentals on the introduction to OCI security and how to start off your account correctly with some of the best practices. This slide does a good job of outlining our other Day One and Beyond series as well. So we have our core series, AI database series, and some others here listed. With that, thank you for joining today's session and have a wonderful day.